Today's lesson is on logarithmic equations, solving logarithmic equations, and they're going to look a little different than yesterday's lesson. So we want to remind ourselves of a few things. So the first thing I have up here are the properties that we've been using all chapter. And we have the product rule. When we have log of x plus log of y, that means that it came from the log of xy, x times y. When we have the log of x minus the log of y, that expansion came from the single log of x divided by y. And when we have n times the log of x, that came from the log of x to the n. So remembering your properties, very important. Also very important to remember that we can take any exponential equation like b to the e equals n and change it to the exponent equals the log, that base b of n. So keeping those items in mind, let's take a look at what we have to do. The first example has log of x plus log of 15 on the left-hand side, and they are separated. So one thing I know that I can do is that I can put them back together. And indeed, that's what we want to do. So using the properties and seeing that I have addition, I know that this side is the same as the log of 15 times x. So now what we have is a log on both sides of the equation. We have log of 15x equals log of 90. The second step says we can anti-log both sides. So officially, we're doing a log inverse log of 15x, and we're doing a log inverse of log 90. And log inverse log are inverse functions, so they undo each other. And we're simply left with 15x equals 90. And no more logarithm equation. Divide both sides by 15. And we get x equals 6. So let's go through it again. We use the properties. And we put these two logs together as a single log. And then since we had a log on both sides of the equation, we could actually just think of dropping that logarithm from both sides. But officially, mathematically, you are anti-logging or log inversing both sides. And then we have a nice, simple equation we can divide by 15. Let's try another one. So on the left-hand side, I have the subtraction of two logs. As a single log, that is 8 divided by x. Now I see I have a logarithm on both sides. Whoops, sorry about that. So since I have a logarithm on both sides, I can anti-log both sides. Log inverse log x, log inverse log 2, and I end up with x equals, oops, I'm sorry, I made a mistake. Sorry. Back up. My darn thing cut out on me. That's 8 over x. We're going to log inverse 8 over x. My apologies. I'm going to log inverse log of 2, and we end up with 8 over x equals 2. Cross multiplying gives me 2x equals 8, and then x equals 4. Now, given that I made a mistake, and I was thinking about the question before this, I do have in the steps to check your original equation with your answer. So if I had gone through this problem and made a mistake, I would not have had a good check. Let's go ahead and check this. Log of 8 in the original minus the log of 4 equals the log of 2. And you can go ahead and put all of that left-hand side into your calculator, and then the log of 2 into your calculator, and you will see that they do equal each other. So checking is important. Number 3 is very similar. Lots of variables there, though. Why don't you stop the video and see if you can get a head start on me, and then come back and check. I have the sum of 2 logs, so I'll put those together with multiplication. So this is the log of x squared plus 2x equals a log of 3. Then I'm going to anti-log, log inverse, both sides. Goodbye logarithm, goodbye logarithm. X squared plus 2x equals 3. We have a quadratic. Let's subtract that 3 over to get it set equal to 0. We'll try and factor this. If not, we would need the quadratic formula for completing this square, but this guy factors beautifully. And we end up with x equals -3 and x equals 1. Now the checks here are very, very important. So if I try and put -3 into the original, I will have the logarithm of -3 plus the logarithm of -1 equals the logarithm of 3. So this is my first check. When you go to type in the log of -3, you will get an error. Because remember, the domain of logarithms is that your argument values need to be greater than 0. So the -3 gets rejected. Let's try the 1. Log of 1 plus the log of 3, those will work out all right. Equals the log of 3. So that should check on your calculator just fine. So we only have x equals 1 as an answer. So here, it does not check because it is not in the domain, and you need to reject it. Number 4. Number 4 looks a little bit different, so we're going to need a different strategy here. This officially is the log of x, take away a 3, equals the log of 4. So this 3 is a plain 3. There's no x on that. So what I'm going to do is I'm going to get the 2 logs together and take the 3 over to the other side. So I'm going to subtract over this log of 4 to the other side, and I'm going to add that 3 over to the other side. So I will have the log of x minus the log of 4, bringing it over, equals, and adding this guy over, equals 3. Now I have 2 logarithms with subtraction. So what can we do? Condense them to a single log with division. Notice this time, we do not have a log on the other side. I went to write it. We do not have a log on the other side. So this is a very different question. What do you think we can do? In all of the other problems, we had the log of something equals the log of something. And in that case, we can just anti-log both sides. So that worked out just fine. In this 4th question, I just have a logarithm equation. So I need you to remember that you can change that to Ben. Just like we started with a few reminders about what we've been doing, this question needs to be put into Ben form. So, common logarithms are base 10. That is our base. Logs equal the exponent, so 3 is the exponent. And base to the exponent equals the number. So base to the exponent equals x over 4. So we have 1,000 equals x over 4. And cross multiplying, we end up with x is 4,000. Let's check that. My darn smartboard is falling apart. Log of 4,000 and then we're going to close that parenthesis and subtract 3 and see if it equals the log of 4. So pause the video for a moment, grab your calculator, let's really do a check here. Log of 4,000, close the parenthesis, minus 3, and then we're checking if it equals the log of 4, and I have 0.60205999913 equals 0.60205999913. So indeed it does check. We have a good answer. So indeed we used a new strategy. And that strategy may come up more often. Let's see, this page looks like we're going to be switching to Ben form as well. So this first question, actually the first few, are multiple choice questions. Let's take a look. Solve for x. I have 2 logarithms on the left-hand side, so I can condense those since it's addition. I will have the log base x. Addition of logarithms means that my terms were multiplied, equals 2. So we have the log base x of 36 equals 2. And now you want to change that to Ben form. Your base is x. Your exponent is 2. X squared equals 36. We could solve by square rooting both sides. And you would get x equals 6. Not plus and minus, because a negative cannot go in for the base. So that is D. Number 2 looks a little more fun. We've got, on the left, 2 logarithms, subtracted this time. And we have a 2 in front of this second one. So let's condense those into 1 logarithm. Subtraction means I was dividing. And that 2 is an exponent for the x. Okay. And it says that this equals 0. So let's switch this to Ben form. Our base is 10. It's a common logarithm. So 10 to the 0 equals 10 minus 3x over x squared. 10 to the 0 is 1. I'm going to cross multiply, and I get x squared equals 10 minus 3x. It's a quadratic, so I want to get 0 on the right. Add over 3x. Subtract over 10. And let's see if this factors nicely. solving it. -5, we better check for our domain. +2. So if we look back at the original, would we be allowed to put in a negative? It's going to be okay there. 10 minus -15. But is it okay here? No, it is not. That gets rejected because of the domain of logarithms. Let's check the 2. 2 is okay here. We would have the log of 10 minus 6 and -2 log of 2. And we'll check that in a second. Put that in your calculator. You should get 0. So that does check. Good answer. And so we are letter A for this multiple choice question. Let's try one more of these and save a couple for class. Let's not do the multiple choice one. Let's try number 4. Looks fun. And then we can try number 6 as well. So let's see what's on this next page. Oh, a bunch more as well. Okay. If we want to try these, if you want to try them on your own, go ahead. What do we see in number 4? I see 2 logarithms, base 3, subtracted. So that means log base 3 of their quotient. All right. And I'm going to change this to Ben form. Base to the exponent equals the number, because it's a single log. So 3 squared equals x squared minus 4 over x plus 2. 3 squared is 9. I'm going to cross multiply. 9 times x plus 2 equals x squared minus 4. Okay. 9x plus 18 equals x squared minus 4. We have a quadratic, we have a squared term, so we're going to bring everything over. I'm going that way this time. Subtract 9x, I have x squared minus 9x, and I'm going to also subtract 18 minus 22. Let's check out some factors. What multiplies to 22? 2 and 11 work very nicely, and their difference can be -9. So we have here 11 and -2. Let's go and see if both of these would check. 11 would give us log base 3 of 121 minus 4 minus log base 3 of 13. So checking that, seeing if that equals 2. Now the numbers going in don't give me a negative or 0, so 11 most likely checks. I'm going to do a quick check on my calculator. So I have log base 3. I'm going to use my alpha window. Alpha window choice 5. If you still need that new operating system, ask your teacher. And when I hit enter, I do get 2. So that works beautifully. 11 checks beautifully. Now how about -2? If I put -2 in here, I would end up with the log base 3 of 0, which we cannot do. Again, the domain for logarithms is that what comes after the log needs to be greater than 0. So that one will not work out. All right. If you want to try this one on your own, you're just going to put it into Ben form right away and see what you can do. For number 6, we have that the log of c equals 0.3214. And they're asking us to find the log of square root of c. So think about the properties. Square root of c means that it is log of c to the 1/2, which means 1/2 log c. And they gave us log c, so we're just going to put that value in there. So we're substituting in the value that they gave us in this particular problem. Log c is given. And all we have to do is multiply 1/2 times 0.3214, and we have our answer. All right, that one wasn't bad, but it was different. Let's take a look at the last page. See what our strategies might be. They all look similar. We've got properties to deal with, and it looks like a single log on one side. Let's try number 8. Log of, the logs are added, so 2x times x plus 5 equals plain old 2. So this is a Ben problem because that 2 is the exponent that goes on 10. So we're going to have base to the exponent equals all of this. 2x squared plus 10x. It's a quadratic, so let's subtract over the 100. And we have 2x squared plus 10x minus 100 equals 0. Looks like I can divide everything by 2. So 2 quantity x squared plus 5x minus 50. And I need to solve the quadratic x squared plus 5x minus 50 equals 0. Let's use the quadratic formula. X equals negative b plus and minus square root of b squared minus 4 times a times c, which is negative 50, all over 2 times a. It's been a while since we did this. So we have 25 plus 200 all over 2. So we have negative 5 plus and minus the square root of 225. Okay, all over 2. Square root of 225 is actually nice. It's 15 all over 2. Let's split it. Negative 5 plus 15 over 2. Negative 5 minus 15 over 2. There's 2 answers here. This is 10 over 2, which is 5. This is negative 20 over 2, which is negative 10. So let's take a look. Can x equal 5 up here? 5 there is okay. 5 there is okay. We can check it. Can x equal negative 10? Negative 10 in here would give us the log of negative 20. That's no good. Reject by the domain. And let's go ahead and check x equals 5. Make sure we didn't make any mistakes. I'll do that in blue. So we should have the log of, we're going to put in 5. Log of 10 plus the log of 10. Nice. Equals 2. And we know log of 10 is 1, and 1 and 1 equals 2. So that's a good answer. It would have factored, but I wanted to go back down the road of using the quadratic formula, just in case you get one that does not factor. All right. Looking ahead here, there's 11 and 12, which were from yesterday's lesson. There's a lot more examples to do together in class. This is to take the log of both sides, if you want to try that one. And this one is to second log. I'll just give you that as a clue. Or if you see this as a ben, it can be a ben as well. One of these days I'll get my board fixed. And our base here will be 10. I'm going to leave this at 26 minutes. See you in class. We can do any of the rest of these together. If you have any questions, be ready to ask them tomorrow.